students, we are here with the new topics and about the new unit to be started. And before starting the new units, we have a discussion. As I will tell you a short story. Okay. And story is very interesting. What is the story? We know that when we are in the practical lab, I found that in the practical lab, suppose if experiment is not done in by us, if it is not getting good result, if we are not going to get a good result, but we are intense and we do like this. Okay, it is not going. I have seen that Saurav Ganguly, when he was in the 10th in the cricket match, what is that? He do it like this. He do it like this. Okay. And so I'm also, when I was in the 10th, and what I do, I just, it's a bad habit to me. I don't know why it came to me. I just switch on the bat switch. Okay. I don't know how many people that type of habits are there. But these are the bad habits. Okay, we should leave it. And in our school, what we have seen that students are what do they leave when they're coming out from the class, they leave some time that their belongings, whatever with them. Suppose sometimes they leave the water bottle, sometimes they leave the pen, sometimes they leave the pencil, sometimes they leave the calculators also, but never leave that one that mobile phone, because they knew about it that if it will left, then it will be not returned by anybody in the school. We cannot return it because it is not allowed in the school campus, isn't it? But now, whenever we are here in the discussion of this chapter about the new chapter, I will not give the name of the chapter. After some time, I will say you that we will deal with a scientist who works in the lab. And when he was doing some experiment, he found that his experiment is not giving the result. At that moment, what happened? He has done a circuit, and he is like me. He is giving switch off, switch on to the circuit. And suddenly he found that somebody has left a needle near it. And whenever he is giving the switch on, it is found that the magnetic needle is deflecting. It is deflecting like this. Switch on and switch off, the magnetic needle is deflecting. Now the problem is that why this magnetic needle is moving? He has a problem, and he is very about that topics. He has to know about this. From where this magnetic needle is deflecting. We know that a magnetic needle will only deflect when there is a magnetic field is there. But in computer, there is no magnetic there. In this around it, so he found that no magnet is there. What is the reason behind it? Then what he has done? Then he comes to conclude that whenever current passes through a conductor, there is a production of magnetic field around it, and that is the name of the chapter. Is what magnetic effects of current means. What there is an effect of current due to what? There is an effect of magnetic field due to current passing through a conductor. From there, Hans Sautet, the name of the scientist is Hans Sautet, comes to know that whenever there is a current passes through a conductor, there is a production of magnetic field around it. Is it clear? After hearing these things, the scientist Ampere got angry because he told me my current is there and I know about the current everything. I have given that one current. Why these people are using? How you can use it? So he ran to his house and asked Mr. Hans Sautet, what happened? Why you have used my current? What is the reason behind it? Then he got angry, and there is a pond near it in his house. He jumped there and started swimming. And at that moment he told him that do you know the direction of the current magnetic field? Then he told, no, I don't know. Just I have discovered that. Hans Sautet told that I have discovered that whenever there is a current passes through a conductor, there is a production of magnetic field around it. He told that suppose if you see that I am swimming, if a man is swimming there, okay, if a man is swimming and a conductor is parallel to him, such that current is going from the direction of the current is such that it is going from the feet of the man and coming out from the head of the man, then the position of the left hand, of this man will give the direction of magnetic field. And that rule is known as Ampere's swimming rule. What is the name of the rule? Ampere's swimming rule. So from there, what we come to know, that whenever a current passes through a conductor such that the conductor is parallel to a man who is swimming, then the position of the left hand will give the direction of what? Magnetic field. By hearing this, a scientist known as what? Scientist, you can say the son of a carpenter, known as what? Maxwell. He got angry. He told him himself that I don't know to swim. And in the year of 2021 or 2022, when there is a current 2000 century, when the teacher like Kanchan Singh, when we will teach, then he will also not know how to swim. Then how can we explain about that one? How can he explain about the magnetic direction of magnetic field? For that reason, he told that he has taken a what? Screw. The son of a carpenter, so he has taken a screw. He told that if the person which one is what above the which one on the top of if the top person gives the direction of current, then the pointer will give the direction of magnetic field. Suppose if we move this one in a clockwise direction, and the current is directed in this way, then the magnetic field will be what? Inward. If we move it what? Anti-clockwise direction, then the magnetic field will be what? Outward. Is it clear? So Maxwell has given a rule. If the tips of the screw gives the tips of the screw give the direction of magnetic field and the screw moves clockwise, then the current will be given by what? By the pointer in the inward direction. If the screw moves anti-clockwise, then the current will be outward, and vice versa. Similarly, if this will give if the tips of the screw give the what? Direction of the current, the magnetic field will be inward. And suppose if it is clockwise direction, if the tips of the screw give the direction of the current, so that it is anti-clockwise direction, the magnetic field will be outward. Is it clear? So this is the rule given by Maxwell corkscrew rule. After that, another scientist came named as what? Fleming. He got angry. What is these things are going there? If someone is saying what? Someone is saying that if you swim, you can find out the magnetic direction of magnetic field. And someone is using what? Cork and someone is using a screw and he is giving that magnetic field. Why? I am a scientist. I should do the practical things. I should know the practicals. I should have. So he has what? He has handled this conductor with his hand. He has taken the conductor in his right hand. And he told that if this forefinger, F-O-U-R, forefinger, not F-O-R-E, forefinger gives the direction of what current, then the thumb finger points the direction of magnetic field and vice versa. Suppose if the current is directed from east to west direction, then the magnetic field is directed from south to north direction. If the current is directed from north to south direction, the magnetic field is directed from east to west direction. If the current is directed from what? West to east direction, then the magnetic field is directed from south to north to south. Is it clear? So if the current is directed from what? If the current is directed from south to north, then the magnetic field is directed from west to east and vice versa. These are the rules given by whom? First one is given by rules for finding out the direction of magnetic field is given by Ampere's, and it is known as Ampere's swimming rule. Second one is given by whom? Given by our scientist Maxwell, so it is known as Maxwell corkscrew rule. And third one is what? Given by Fleming, so it is known as Fleming thumb rule. So there are three rules given by the three scientists. Is it clear? And what we have come to know, we come to know that the starting of this one, everything is given by whom? By our great scientist known as Hans Oersted. Is it clear? And the name of the chapter is Magnetic Effects of Current. By knowing this things, that about the directions and about the magnetic effects of current, two friends, like in Solet, two friends are there, Jay and Biru. There are also two friends. Here also two friends came, named as what? Biot and Savard. They came. Why they came? Biot and Savard. They came in front of this scientist, and they asked him. They asked them one by one, what you have done? First they have asked Hans Oersted, what you have done? Hans Oersted told that, I come to what? Discover that whenever there is a current is there is a production of magnetic field around it. Okay, very good. Next one, they asked, who are you? He told, I am Ampere. I told that Ampere swimming rule. What you have told? He told that if a man swims such that he is moving in such that a conductor is parallel to him and the direction of the current is such that it is going from the feet of the man and coming out from the head of the man, then the position of the left hand will give the direction of the magnetic field. Okay. And then who came? Maxwell. He asked, what you have done? He told that if I take a screw, so that the top of the screw, that means tips of the screw, give the magnetic direction of the current, then the pointer will give the direction of magnetic field. If the screw moves clockwise, then magnetic field will be inward. If the screw moves anti-clockwise, then the magnetic field will be outward. Then came planning. He asked, what you have done? What you have told? He told that if I hold a conductor by my right hand, and if the four fingers of my right hand give the direction of current, then the thumb finger points the direction of magnetic field and vice versa. Then they told, okay, you all done a very good job, but I want to know that what is the magnitude of these magnetic fields. Then all ran away. But these two friends kept them sit there, and we will discuss about that one. And that two scientists are Biot, Savard. Name of the what? Biot and Savard. And they have given a rule known as what? Biot-Savard law. And another name of this one is what? Ampere's theorem. Be alert about the name of the theorem is what? Ampere's theorem or Biot-Savard law. That is the main name of the topic. They have taken a conductor. They told us, if from this conductor if current I is going, and if we take a small length element of this conductor, then we know that magnetic field around it will be around it. Suppose they have taken a point P here. Okay. And this point P is at the distance of R from this point O. That means length element. And the angle between them is what? Theta. They told that if the current is more, then there will be magnetic field there. Small length element is there, so magnetic field is small and will be given by dB. As we know, electric field is given by E, but magnetic field is given by B. Be serious about it. So here the small magnetic field is there, dB. So it is found that they told that dB directly proportional to I. Means what? If the current is more, magnetic field is more. Again they told that if this dB is also directly proportional to dl. What is that dl? dl is the length of the conductor. If the length of the conductor is more, then magnetic field is more. Again they told that dB directly proportional to sin theta. Why sin theta? I will explain it later on. But they have told that dB is directly proportional to sin theta. And again dB directly proportional to what? 1 by r square. Is it clear? And when they combine all these things, they come to know that dB directly proportional to ideal sine theta divided by r square. Is it clear? And when you utilize something, when there is a proportionality sign is there, you can to put that what k, and k is a constant of proportionality. So the result is how much? dV is equal to k into ideal sine theta divided by r square, and that one is given by whole. That one is given by